How is it going, everyone? Welcome to my channel Cyber Hashira. I'm sorry for not uploading any new video for over a month. I had to relocate to another place and find a new home. Well, I finally found a nice peaceful place to live, so now I will continue to upload new videos to this channel. This is going to be my 9th video on OpenSSL, and in this video I will show you how to set up your own 2-tier PKI, which includes a root CA at the top and an issuing CA. The issuer will have the capability to issue a WebServer certificate, a Codesigning certificate, and a user certificate. So without further delay, let's dive into it. Before I walk you through with the setup, I want to take a few minutes to give you a quick overview of PKI. PKI stands for Public Key Infrastructure. PKI is a combination of various components such as hardware, software, policies, roles, and procedures which are required to manage a digital certificate. PKI is a trusted environment that lets you create, organize, distribute, and revoke digital certificates. One of the main components of PKI is Certificate Authority, or CA. A certificate authority is a trusted party which is responsible for issuing, storing, managing, and distributing a digital certificate. A digital certificate, as you might already know, is used to identify a subject. There is a separate video about digital certificate on this channel where I have talked about digital certificate in detail. Please do check out that video if you want to learn more about it. Anyways, there are two types of certificate authority, a public CA and a private CA. A public CA provides its services for the general public. IdenTrust, DigiCert, GlobalSign, Entrust, Let's Encrypt are all examples of a public CA. You can contact them to obtain a trusted digital certificate. And depending on the type of certificate that you're applying for, you may have to pay some amount of money. Most of these public CAs are usually trusted by an operating system and an internet browser such as Chrome, Firefox, Opera, or IE. A private CA, on the other hand, is usually owned by an organization. These are used by a company to issue certificate for its worker or devices that they are going to use internally. The certificates issued by a private CA is only trusted internally within that organization. A certificate authority can be further distinguished as a standalone CA or an enterprise CA. There is just one main difference between these two. An enterprise CA is a part of a domain, whereas a standalone CA is not associated to any domain, therefore the name standalone. A certificate's trust chain includes certificates from all trusted parties. At the top, there's always root CA certificate, followed by an intermediate or an issuing CA certificate, and an end user certificate at the end. A certificate chain enables us to see all trusted parties. For example, in this image, Outlook.com is the end user certificate. This certificate was issued to Outlook.com by DigiCert Cloud Services CA1, and at the top there's DigiCert Global Root CA. A root CA is the topmost CA in a CA hierarchy. A certificate's trust chain will always start with a root CA, and then it branches over to other CAs below that. A root CA always uses a self-signed certificate. A root CA is used for issuing certificates to a subordinate CA or an issuing CA. An expired or a revoked root CA certificate would affect the entire trust chain. Once a root CA certificate expires, it is not an easy process to correct the entire trust chain. Now that's one reason why a root CA certificate usually have a long expiration period. The validity period of a root CA certificate could be anywhere between 5 years to 30 years, or maybe even more. And because root CA is the most critical component in a chain of trust, a root CA operates in a highly secure environment and are mostly kept offline or isolated. A subordinate CA, also referred to as an intermediate CA, are second in the chain of trust. They are trusted by the root, so they always operate under a root CA. A certificate of a subordinate CA is signed by a root CA. They don't use self-signed certificates. The role of a subordinate CA is to issue certificates to an entity. This entity can be a user, a device, or a system such as a web server. They can also issue certificates to another intermediate CA. When compared to a root CA certificate, a sub-CA certificate will have a shorter expiration period. Certificate Revocation List, or CRL, contains a list of all certificates that have been revoked. A CRL is a database where the serial number of a revoked certificate is stored along with some other information such as a revocation timestamp. All this information is then signed by the CA's private key. There are two types of CRL. There's a base CRL and there's a delta CRL. Base CRL contains all revoked certificates. On the other hand, a delta CRL only carries the latest updates made to the CRL. Let me explain what I mean. A base CRL will eventually grow in size as more and more revoked certificates are added to it. Now that's where delta CRLs are useful. Instead of downloading the entire base CRL, a client can simply download the updates made to it. Now because these updates are smaller in size compared to the actual base CRL, it is easy for the client to keep an up-to-date list of revoked certificates. And now I will show you how to set up a root CA using OpenSSL. This root CA will then issue a certificate to my issuing CA. My issuing CA will have a template to issue a WebServer certificate, a Codesigning certificate, and a user certificate. I will show you how to generate some of these certificates with the help of an issuing CA. And finally, I will show you how to revoke a certificate using OpenSSL. Let's begin. Alright, so the first thing we are going to do is set up a directory and file structure for root CA and issuing CA. I've already prepared some commands in Notepad. I'll just copy paste those commands here. I will also upload my notes for this video on GitHub. You can download my notes from the link in the description below. Okay, so here's my first command. So make directory my CA, and inside my CA I need my root and my issuing. I'll hit enter. Let's move into my CA, and inside my CA I have my issuing and my root. And now I'm going to switch to my root directory. Okay, this is where we are. So my CA, my root. Now inside my root I'm going to make some more directories. So here's the next command, paste, and I will hit enter. So I'm making a directory called private cert issued cert CRL CSR data, and I will change the permission of private to 700. These are the directories. Private will be used to store the private key. Issued cert will be used to store the issued certificates, like the certificates that this root CA is going to issue. Those certificates are going to be stored here. The data directory is going to store some information such as the index of those certificates, the serial number, the CRL number, and other information. CSR is going to be used to store the certificate signing request. CRL is going to be used to store the certificate revocation list. And the cert will have the certificate for my root CA. Next, I'll generate a file containing some random data which will be used to seed the OpenSSL's RNG. Here's the command for that. Copy, paste. So OpenSSL ran-hex-out private, and the file name is .rand16. So I will be writing 16 bytes of random data, and I will be changing the permission of that file to 600. Okay, let's do ls-la private, and here's our file and read write permission 600. Now I'll be generating some files inside the data directory. So here's our next command. So inside data directory, I will be creating a file called index.dat, which will be used to index all the certificates issued by my root CA, and a serial number, which is actually 8 bytes of randomly generated data. This serial number file will be used to seed the RNG for generating random serial number. And this is the CRL index number. It starts with 1000. And I'm going to change the permission to read write for all files that are inside the data directory. I'll hit enter. Let's do ls-la data. So we have CRL number, index.dat, and serial.dat. Here's what my directory structure looks like. So inside my CA, I have my issuing, my root. Inside my root, I have cert directory, CRL, CSR, data. Inside data, there are 3 files. There's CRL_number, index.dat, serial.dat, and there's issued certs and private. And now I will set up the directory structure for my issuing CA. So I'll go back. Let me clear the screen. Just like root, I'm going to make some directories inside my issuing. So here's our next command. So this is the same structure like root. So we have cert, CRL, CSR, data, issued cert, and private. And the private has a permission of read write execute for the owner. Next, I'm going to generate some random data so OpenSSL can use it as a seed. Here's the command for that. OpenSSL ran-hex-out private.rand is the name of the file. It's a 16-byte data, and I will be changing that permission to read write for this file. Let's do ls-la private. Here's the file, read write permission. And now I'm going to generate some data files. So here's our next command. And ls data. These are the files that we generated. CRL number, index.dat, and serial.dat. And now let me clear the screen. This is what our directory structure looks like. So inside my CA, I have my issuing, which has cert, CRL, CSR, data, and there are 3 data files inside data, issued certs, and private. And we have a similar structure inside my root. And this is the directory structure we will be using for our demo today. All right, let's generate some keys. So I'll start with my root. The first step is to generate a configuration file for my root. So I already have something copied in my notepad. I'll name this file as my root.cnf, and I'll simply paste everything here. So inside this configuration file, we have the settings for my root CA. Let's start with CA defaults. So the first thing we see under CA default is a dir. This is the directory where my root exists. So this is the location where OpenSSL will look for all other files. So inside my root, there's cert, CRL, issued cert, and it goes on like that. Whenever OpenSSL needs to access some files, it will just simply follow this directory structure. For example, this configuration file will tell OpenSSL to generate the private key inside the private directory of my root, and the name of that file should be myroot.key. It will also tell OpenSSL to generate the certificate by the name of myroot.cer, and it also tells the location of the CRL file, the serial number, the index, the default message digest to use, number of days the root certificate is valid for. So this is 3650, 10 years. And the policy that this our root CA will be following. Let me scroll down a little bit. So the policy that my root CA will be following is called policy any. And inside policy any section, there are some fields that has been marked as supplied, optional, or match. Let me explain what this is. So if a field has match set as the policy, it means when I'm trying to generate a certificate, the organization name should match. For example, if the organization name that I'm going to set here is, let's say for example, Cyber Hashira, then the certificate that my issuing CA, or sorry, my root CA will be issuing should also have the same organization name. If it has a different organization name, then that certificate request will be rejected by root. Next policy is supplied. Supplied means that when I'm going to submit a certificate request, the country name and the common name should be supplied, which means these fields should be supplied in the certificate request itself. So optional means that this data is optional. If I want, I can provide a state or province name. And similarly, I also have organizational unit name set as optional. So if I want, I can provide this information, or I can totally skip it. Let me scroll further down. The request section here contains the default settings that will be used for generating a certificate request. For example, default bits is set to 2048, which means if I were to generate RSA key pair, that key pair will be of size 2048 by default, unless I specify some other size. The message digest that will be used is SHA-256 with RSA, and it will be using the settings that I've described in the request distinguished name section, this one. Request distinguished name specifies the messages that will be displayed on the screen when OpenSSL prompts us to input some information. For example, when OpenSSL needs to know the country for generating a certificate request, it will display country name, 2-letter code. That will be the message that will be displayed on the screen. Similarly, if it needs to know the locality name, it will just display the message locality name, and it will just like wait for your input. Now, if you want, you can change it to whatever you like. For example, I can change this section or this message to, like, I'll backspace this and I'll write, what country are you from? And for city, I'll just change it to, which city are you from? So next time when I'm going to generate a certificate request, this is a message that will be displayed when OpenSSL needs to know my country name. And this is a message that will be displayed when it needs to know the locality name. Also, request distinguished name section has some default values. So as you can see, the country name, state, and the locality name has been, I've set it blank, so there is no default values. For organization name, the default value is Cyber Hashira. For organizational unit, it's PKI, and the email address is pki@home.lab. And what else do we have? All right, so these two sections contains the extensions that will be used. So for example, v3ca contains the extensions that will be used by my root CA. So these are the key usage. It's going to have a critical key usage of digital signature, CRL sign, and key cert sign. Similarly, the basic constraint is going to be critical. CA will be marked as true, and the path length will be set to 2. So there will be 2 certificates under it. This is the CRL distribution point. Although this URL does not exist, I don't know. If I want, I can set up a web server with this URL and just point it to my root.crl. I can do it that way. This section contains the extensions that will be used by my issuing CA. So again, it has the key usage for my issuing CA, the CRL distribution point, which will point to the URL where my Issuing CA will store the CRL, and this is going to have the authority information access. Again, this is the root certificate. So these are all the extensions for my issuing CA and my root CA. All right, I'm going to save this file, exit. And now I will generate private key for my root CA. So I already have the command. I'll copy it and paste it here. So OpenSSL ecparam-gen key, I'm going to generate an ECDSA key of this curve, and this command will be used to encrypt that key. Obviously this is a private key, and also this is for my root CA. So it's a good idea to encrypt that private key. So I will be using AES-256 key. And once a private key is generated, I will be changing the permission of that private key to 400, which is just read. Right, I'll hit enter. And here's the password, which will be used to generate a secret key to encrypt the private key. Private key is generated. Let's have a look at the permission. So here's our private key, and it has a read permissions. So now we have generated a private key. Next step is to generate a certificate. So here's our next command. So OpenSSL request -config. Now -config will tell OpenSSL to use the settings that I've described in my root.cnf file. The key that will be used to generate this request is going to be my root.key. This is the private key. This is a new request. It will be converted into a certificate. SHA-256 is going to be the message digest. And the extension that will be used to generate this root CA certificate is going to be v3ca, as we described in our myroot.cnf. It's going to be valid for 3650, so 10 years. And this is the name of that file. Although we don't have to mention all of this because this information is mentioned in the configuration file. I'm going to hit enter, and here's a password. So I made some changes in my root.cnf file. If you remember, I changed the message for country to what country are you from. So I'll just enter CN, state, city, I'll just leave it blank. Organization name, Cyber Hashira. That is, this is the default value that I had set. I'm going to hit enter. Similarly for organization unit, I'll leave it at PKI. Common name, I'll name it as my root. Email address, I'll just leave it at as pki@home.lab. And that's it. Now if I run the command, let me clear the screen. Now if I run the command OpenSSL x509-in cert no out-text, here's our root certificate. So it is an ECDSA key, and this is the information that I had entered when I was generating a certificate request. And if I scroll down, I see the extensions. All right, so now our root CA is fully set up. Now let's go ahead and set up our issuing CA. Just like root, I have prepared a separate configuration file for my issuing CA. I'm going to call it my issuing.cnf. And here's the template. Let me scroll up. Here I have the directory and file structure of my issuing CA. So the private key will be stored in the private directory. The certificate will be stored in the cert directory. Similarly, we have the CRL. I've also mentioned the default message digest to use, which is going to be SHA-256. The certificate for my issuing will be valid for 1826. That's 5 years. And this is going to be the home location of my issuing. I've defined a policy for my issuing called policy any. Let me scroll down and show you what it looks like. Inside policy any, I have set all fields as optional except for the common name. It has to be supplied. These are the default values to be used for certificate request. The key pair that I will be generating is going to be RSA key, and it will be of size 2048. The message digest is going to be of SHA-256. It's going to request for the distinguished name information as described in rec distinguished name. And here's our rec distinguished name information. Let me scroll down. These are the messages that will be printed on the screen when OpenSSL is requesting for certain information such as country name, state, locality, etc. And these are the default value. So I haven't set any default value for country, state, or locality. There is a default value for organization name, organizational unit, and email address. And then I have mentioned some templates for different type of certificates. So for example, if I were to generate a user certificate, this is the extension that will be used. The certificate will have a critical key usage with non-repudiation, digital signature, key encipherment, and the extended key usage of client auth, email protection. I've also mentioned the CRL distribution point to use, CDP, and the authority information access, which actually points to the issuing CA certificate. And at the top, the basic constraint, obviously it is set to false because this is not a CA certificate, it is going to be a user certificate. We also have the server certificate, and these are the extensions that I have set to it. And this is the code signing extensions. One second, I think I made a mistake here. The extended key usage for this one has to be code signing, code signing. And further down, I have information related to CRL and OCSP. I will not be discussing OCSP or demoing OCSP in this video. That I guess I will do this in some other video. So for now, this is a template I will be using for my issuing CA. I'm going to save the changes, exit. All right, and now I will generate the private key for my issuing CA. So OpenSSL gen RSA-AS256 out private, and I'll name this file as my issuing.key 2048. And here's the password to encrypt my private key. Private key is generated. Now I will change the permission of my private key. All right, done. I'll clear the screen. And now I need to generate a certificate request for my issuing CA. So here's our next command. So OpenSSL rec-config, I will be using the information that I mentioned in my root.cnf. So that's why I'm specifying /my root.cnf. The key that I will be using is going to be my issuing CA's private key, which is in my issuing.key. It's going to be a new request, which is going to use SHA-256 as the message digest algorithm, and the output of this command or the CSR will be stored in my issuing.csr. I'm going to hit enter. Okay, it's asking for the country. I'll set it to India, UP, Noida. I'll just use the default values. Common name, my issuing, yeah, default. Now that I have the certificate signing request for my issuing, I'm going to get it signed by my root CA. So here's our next command. I'll clear the screen. And here's the command to sign the certificate request. So I'm going to run the command OpenSSL CA-config, and I'm going to use the configuration file of my root.cnf. The reason why I'm doing that is because the extension that I created for the intermediate CA exists inside my root.cnf. So I'm specifying -extensions v3 intermediate CA. This certificate is going to be valid for 5 years. no text will be displayed, and the message digest that I will be using is going to be SHA-256. Input is going to be CSR myissuing.csr, and the output will be stored in the cert directory myissuing.cer. I'm going to hit enter. Okay, so it's asking for the password for my root. Okay, now it's asking, do you want to sign the certificate? Yes. Commit. Yes. And the certificate is generated. All right, let's examine the issuing CA certificate that we just generated. So OpenSSL x59-in cert. Okay, no out dash text. All right. Okay, so the issuer of this certificate is my root. The subject is my issuing. And these are the extensions that I set in the configuration file. Those extensions are being used here. And yeah, this is my issuing CS certificate. There's just a few more steps I need to do. So let me clear the screen. First, I will change the permission of, one second. So I will change the permission of my issuing CA certificate to 444, read write, read write, read write. Next, I'm going to create a CA cert file. So I'm going to concatenate cert myissuing.cr and myroot.cr into cert.cer. I will also change the permission of cert. So chmod 444 cert cert.cer. And now I will verify my issuing CA certificate. So OpenSSL verify-ca file cert ca file, sorry, cert.cr, and my my issuing CA certificate is in my issuing.cr, and it's verified as okay. All right, so now we have set up my root CA and my issuing CA. Now I will show you how to issue certificates using my issuing CA. I will try to issue the code signing certificate, or I specified user certificate, code signing certificate, and the web server certificate. I'll try to generate one or two of those certificates, and I'll show you how that works. I'm going to start by generating a certificate for a web server. So for that, I will create a new directory. So mkdir, I'll just call it WebSSL. Okay, just imagine that I'm a web admin and I am logged in on my machine. I will be generating a private key, and using that private key, I will be generating a certificate signing request, and that CSR will be submitted to my issuing CA to get a signed certificate. So let's try generating the private key. So OpenSSL gen RSA AS256 out, and I'll just call it webssl.key. And okay, always encrypt your private key. Private key generated. I'm going to change the permission of this private key. Actually, I don't need to do that because by default, when you generate a private key, it always has the 400 as a permission. But anyways, next step is to generate a certificate request. So I'm going to run the command OpenSSL request. The key is webssl.key. It's going to be a new request, and I want to use SHA-256 as the message digest. And I want to output this CSR into a file called webssl.csr. I'll hit enter. Okay, it's asking for the password. Okay, so country name, CN, PC, leave it blank. Okay, all right, I'll just call it Cyber Hashira. Web admins. Common name, I'll just name it test SSL. Leave it blank, blank, enter. All right, so the certificate signing request has been generated. And now I will submit this request to my issuing CA. So I'll clear the screen, OpenSSL CA config, my issuing.cnf, because this is where the template for the server certificate exists. The extension that I will be using is called server cert. This certificate is going to be valid for 365 days. I don't want any output to be printed. The message digest is SHA-256. Input is going to be WebSSL.CSR and output is going to be WebSSL.CER. I'm going to hit enter. Okay, it's asking whether I want to sign the certificate. I'll just say yes and commit. Now if I look at the index file of my issuing, so cat my issuing data index.dat. So here's the index of the certificate that I just generated. So if I execute this same command again, which I issued earlier to generate a WebSSL certificate, let's see what happens. I'm going to enter the password and it says the matching entry has following details. So there is already a certificate for this common name. All right, let's examine the WebSSL certificate. So OpenSSL x509-in WebSSL.CER no out-text. And if I scroll up, I can see that the issuer is my issuing and this is subject test SSL. And these are the key usage that I set from the template. And because I don't need the CSR anymore, I would simply delete the CSR file. And now we are left with our certificate and the key. Let me try generating a code signing certificate now. So I'm going to get out of here and create a new directory called code signing, cd code signing. Maybe I should use a different name. I'll just okay, I'll just name it dev team. Okay, dev team. All right, so for code signing, the first command that I will be executing is OpenSSL gen RSA-AS256, and I'm going to output this to dev key. Is the password. Okay, now I'm going to generate a certificate signing request. So OpenSSL request key is going to be dev key, new SHA-256, out dev CSR. Okay, sure. Let's see. Development. I'll just name it dev team. Blank, blank, blank. And here's our CSR. Now I'm going to submit the CSR to my issuing CA. So I'll clear the screen and execute the command OpenSSL CA-config my issuing.cnf extensions code signing cert days 365 no text SHA-256 dev CSR and output dev.cer. I'll hit enter. Okay, what did I do? That's not how you spell extensions. S. Enter. Okay, sign the certificate. Yes. And commit. Yes. All right. So let's have a look at the index of my issuing CA. And now we have 2 certificates in that index. Let's examine our dev certificate. So OpenSSL X59 in. No out dash text. And here's our Codesigning certificate. These are the extensions issued by my issuing to DevTeam. And now I will show you how to revoke a certificate. And for that, I will go in my issuing directory. Okay, so the first thing that I need to do is generate a blank CRL file. So OpenSSL ca-config and then gen CRL out CRL. I'll call it my issuing.crl. I'll hit enter. Okay, blank CRL has been generated. Let's examine that CRL file and see what's in it. So OpenSSL CRL-in CRL my issuing.crl no out dash text. And at the moment it says no revoke certificate. There are no revoke certificates because we haven't revoked any. So let's revoke a certificate. Let's revoke those 2 certificates that we generated earlier. So OpenSSL ca-config my issuing.cnf and revoke dev team dev.cer. All right, it says the database updated, certificate has been revoked. Now we need to generate the CRL again, so it updates the information into it. And the command is OpenSSL ca-config my issuing.cnf gen CRL out CRL and this one. All right, so the CRL file is updated. Let's examine the CRL file now. So OpenSSL CRL-in CRL my issuing.crl no out dash text. And now we see the serial number of the certificate that was revoked. Let's revoke another certificate. So OpenSSL ca-config my issuing.cnf revoke, and I'm going to revoke my WebSSL certificate. Okay, certificate has been revoked. And now I will update my CRL. So OpenSSL ca-config gen CRL out CRL my issuing.crl OpenSSL. What did I do? Oh, I forgot to mention my configuration file. Okay, CRL is updated. Let's have a look at the CRL. Let's clear the screen first. So OpenSSL CRL-in CRL my issuing.crl no out dash text. And now we have 2 CRLs, or sorry, 2 revoked certificates in this database. Whew, that was a long video. Thank you for your patience. So today I showed you how OpenSSL can be used to set up a certificate authority. I taught you how to generate certificate requests, get those requests signed by a CA, and revoke a certificate. I hope you learned something new from this video. Please use the comment section if you have any questions. I'll be happy to answer them. And I'll be uploading my notes to GitHub. Link will be in the description below. And as always, thank you so much for watching this video. Leave a like if you like this video, and please subscribe to my channel if you haven't already. I'll see you in the next one. Bye bye.